Hello and welcome. This video discusses the next steps to take after learning the basics of regular expressions. We will cover advanced topics and tools to master regular expressions, to take your regular expression skills to the next level. Now let's explore some advanced regular expression pattern concepts. On the left, we'll delve into advanced features like lookaheads and lookbehinds, which allow you to match patterns based on what precedes or follows them, without including those surrounding characters in the match. Next, we have named capture groups that assign names to parts of the matched text, making it easier to extract and work with specific portions. Then we have atomic groups, which prevent backtracking, ensuring more efficient matching. And finally, we will touch upon recursion in patterns, which will allow you to match nested or recursive structures. On the right, we will look into performance and tools. First, we will discuss pattern optimization techniques to improve the efficiency of your regular expressions. Then, we'll discuss regular expression testing tools to help you debug and validate your patterns. After that, we will explore language-specific application programming interfaces or APIs that provide regular expression functionalities tailored to different programming languages. And lastly, we will see some real-world applications where regular expressions are used in various practical scenarios. Let's talk about performance optimization in regular expressions. First, we will see how to avoid catastrophic backtracking. Nested quantifiers can cause exponential slowdown. For example, the problematic pattern on the screen, our open parenthesis a plus close parenthesis plus $, is highly inefficient due to nested quantifiers. The optimized pattern, our plus $, avoids the nested quantifier, which prevents catastrophic backtracking and significantly improves performance. Next, let's discuss how to use anchors strategically. Anchors limit where the engine searches for matches. The code example demonstrates this. Without anchors, the pattern, our error, searches the entire text, which is slower. With anchors, the pattern, our $error $, limits the search to lines containing error, making it faster. The caret matches the beginning of the string. The $sign matches the end of the string. The period matches any character except new line. The asterisk matches 0 or more occurrences of the preceding character. Thus, the expression matches the entire line containing the word error. Now let's check out some essential testing tools for regular expressions. First, we have Regex101.com. Its features include real-time pattern testing, multi-language support, detailed explanations, and code generation. Second, we have RegExr.com. Its features include an interactive cheat sheet, community patterns, syntax highlighting, and test suite creation. Here are some more testing tools for regular expressions. First, Regex.com. Its features include visual regular expression diagrams, step-by-step debugging, multi-language support, and pattern flow visualization. Second, RegExBuddy. Its features include a professional desktop app, library management, code generation, and comprehensive tutorials. Let's see the language-specific application programming interfaces, or APIs, for regular expressions. First, Python. The code shows import re, then pattern equals re.compile, then r/d plus inside quotations, then result equals pattern.findAll, then text inside parenthesis. This is a rich regular expression module with compilation and caching. Second, Java. The code shows pattern space pattern equals pattern.compile, then quotations \d plus quotations, then matcher space matcher equals pattern.matcher, then text inside parenthesis, then matcher.find open parenthesis close parenthesis. These are pattern and matcher classes for robust processing. Let's explore some real-world applications of regular expressions. First, data validation. Some of the use cases are email format validation, password complexity enforcement, phone number formats, and credit card patterns. Second, log analysis. Some of the use cases are error pattern extraction, performance monitoring, security threat detection, and user behavior analysis. Let's discuss some security considerations when working with regular expressions. First, DDoS attacks. The code shows a vulnerable pattern, which is our open parenthesis a plus close parenthesis plus. A safe alternative is our a plus. Avoid nested quantifiers that cause exponential backtracking. Second, input validation. The code shows pattern equals rect escape open parenthesis user input close parenthesis. And our caret open square bracket a hyphen z capital A hyphen z 0 hyphen 9 close square bracket plus $sign. Always sanitize and validate user provided regular expression patterns. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.